Today I want to run through some of the different types of UV sterilization processes for these residential reverse osmosis systems, or really any type of water system. All the things I'm going to be talking about today are pretty much only for low volume, low flow residential reverse osmosis, things that would go under the sink, things you might see inside of a standalone filter. But yeah, there's two major types. There's the fluorescent style, and then there's the LED style. We'll cover both of those, but we can get started in kind of the basics of how it works. So right now I've got a express water 12 watt UV here. Looks like it's rated for 1 gallon per minute. With this package you get the ballast. Your ballast is what's going to convert your AC power over to something that's usable by the fluorescent UV light. This is integral. This is required for any type of standard UV. It's going to make sure the lamp works. It's not going to draw too much power when it's running. It's not going to heat up too much. These are absolutely required when you're using this type of UV. So this thing, or this little machine, has a couple of components. The most important being the UV bulb. It looks a lot like a fluorescent light because it is. The second component is going to be the quartz sleeve. I know it looks like glass, but UV cannot pass through standard glass. So we have to use a quartz element here because the UV will actually pass through that and get into the water where it can do its work sterilizing and killing everything living in the water, which is our goal here. So to put this together, some of them are a little different than others, but this one only has a screw on the top side, nothing on the bottom, it's all fixed. The the quartz tube goes into there, gets screwed on with the gasket in there, and then the UV light drops in. We're going to leave it out a little bit for right now so you can see it running, but then once that goes in, you've got your 4-prong plug here. It'll only go in one way, so, or I guess 2 ways because it's square, or it's rectangular, but when it's fully completed, that UV will sit inside there with that cap on it. One thing about UV is it's really bad for you to look at. It will make you blind. It's something that's dangerous that you should treat like welding arcs or anything like that. We'll show you a little bit for this demo, but I want to make sure that everyone's cautioned around looking directly into UV light. So this is about the most basic system that you can do. This is a UV that comes on when the power comes onto it. So there's no flow switch here. All there is a power connection. When this gets power, that light goes on. So plug it in here, flip our switch, and you can see, I'm not looking at it, but you can see that light is glowing. All right, so we'll flip our power off. There we go. Very simple. This is about the cheapest, most basic you can do. But as you noticed, anytime there's power to the machine, it will be on, it'll flow. So that's going to dramatically decrease the usage of your lamp. And if there's no water flowing through the housing here when the lamp is on, it's just going to heat up. It's not really doing anything. You know, it can sterilize 1 gallon a minute. So we really want to run 1 gallon or less a minute through it. If we're not doing anything, that light is just there heating up, something that's not great. So let's jump over to another style here. This is just one that I have laying around the shop that I've used on another machine. So you'll notice it's basically the same, except the ballast has a little switch on it. And this is a flow switch. All it does is it communicates to the ballast when there's water flowing. So we'll hook it into my little test rig here. We've got just a basic reverse osmosis booster pump here, and then a little visualizer so people watching can see. I'm going to go ahead and plug the UV ballast in, switch that on, and that light's not on. So we've got the ballast that's running. We see that it's got the green indicator light, but that light isn't on. So now let's introduce some flow. And you can see as soon as that flow starts, the light turns on. Now, if we dump the flow or we go back to 0, that light's going to stay on for a few minutes, probably 3 to 5 minutes. These lights don't like to be cycled, so they like to come on, they like to heat up to the temperature that they're meant to operate at, the voltage can stabilize, and they can do the work that they're meant to do. So this is a more complicated system, but it works a lot better. So you've got more wires running, you've got some high voltage, but this is incredibly low voltage, so this is very, very easy to manipulate wire. Now, we'll get into the systems that are more modern. These still use UV. They still use the same, nanometer wave, or was it 454 nanometer wavelength that all UV that is meant to kill things, it's meant to kill bacteria, we'll use. Actually, I'm going to grab a longer here. So, we've got two different UV systems here. The first one I'll talk about is the 123 filter LED UV. This also has a flow rating of 1 gallon per minute, and it runs on 24 volts. So this transformer right here goes from 120 to, or I guess 240 as well, down to 24 volts and 1 amp. It's a very low power device. So, quick connects on both sides, very easy. It's got a flow direction, so we want the flow to come in there. So let's run that from the pump. It's coming out here. All right, so plug that in. We've got no indication that it's on. There's no water flowing, right? So we've got it plugged in. We've got no water flowing, but turn the flow on. We can hear that water rushing through there. We can see the little indicator light that it's on. So these tiny little UVs have much longer service lives than your standard fluorescent UVs, but you can't replace the bulbs, right? So the bulbs are hard sealed inside of here. I can't take it apart without destroying it. But these are just much, much more simple devices. LED versus the ballast, the everything. It's also part of a 24 volt system. So generally, if you're running a pump on your RO system, it's running 24 volt anyway. So you don't actually need this transformer, which is really nice. All right, so let's drop the flow, kill the power to everything. Let's try another one of these. So the second one that we have here is the WaterDrop UV Sterilizer. Looks like this one is running about 0.5 amps. We're still on a 24 volt system. This is a 0.5 amp transformer rather than a 1 amp. These are super cheap and available, so I don't think that really matters. But we've got, again, a fully self-contained unit. So again, flow is in, flow is out. Plug our quick connects in here. We've got no pressure on this system, so it doesn't really matter if we're using collars or not. But again, we'll plug it in. We've got power running to it. We've got no flow. So no power, no flow, no UV on. Now we add some flow, and we see that UV click on. So now we know that it's sterilizing actively. We know that it's working because it does have that indicator light on it. Again, this is still running at the 454 nanometers. It's the correct wavelength to kill bacteria, but we don't know the power. We don't know the dosage. So sending some emails right now to WaterDrop and iSpring to see what type of UV LEDs they're using to hopefully make sure that we can verify that 1 gallon per minute rating. Again, all of these ratings are going to be made on water that is from a clean source. It's usually done post reverse osmosis, so you know that you don't have as much turbidity in the water. Turbidity really hurts UV because you need light to pass through water, and turbidity keeps light from passing through the water. So you need really, really clear water for this to work, and it does work. This is an amazing final step, especially if you're worried about bacteriological or viral components. This can just knock out all of that as long as you're running the correct flow systems or the correct flow ratings through the devices. So I'm a huge fan of UV for RO systems, especially when there's going to be bacteria like RV tanks and whatnot. And these new LEDs are incredible. They have a much longer life, they work much better, and I really can't say enough good things about them. So I'll post all the links to all this stuff. I don't really see a difference between the WaterDrop one that we've got here running now and the iSpring. A little bit different form factor. This one's stainless, this one's plastic. You know, I think they're both great devices. So if you're looking to add an UV to your system, this has an integrated flow switch. It has everything you need to quickly drop in just a little component, usually around $100. I'll post links to everything. But these work great, and I would highly recommend them to anyone who's looking to add UV to their RO system. All right, thank you, and tune in for more of these little guides.